think it's day 4 of C. We're doing head for C. And let's get on with it. So I'm going to go ahead and reset my system. You need to remember how to do that. Using tmux, I'm going to cd into our lab for this session. I forgot what we called it though. I think we call that head for C, right? Head for C projects. Probably, I don't know if that's the best thing to call it. I might rename it later, but for now, let's just go ahead and go to that. Let's open a tmux session in here because I'm going to be using it. And I'm just resizing over here so you guys can talk over here. If you have chat or questions, this is an AMA session, so, shoot if you have questions. I do want to take a look at the stream and make sure it's working real quick. Looks like we are streaming. Haven't got anybody here yet, but so yeah. All right, we're gonna go back up. Get going on this. It's right here. Cheers. So we're going to be here for 90 minutes, just working through this. And pick up where we left off. You have a neat bourbon? Oh, that sounds good too. That sounds really good. And I don't think we need to look up anything over here. Oh, we still have our book where we left off. So we were actually going through the compiler. Now, there's something I want to show you about this. We can go through and read the book, but after we get done through this part, I want to show you the compiler simulator that was shown to me by some other people from the community, and I think it's really amazing. I want to make sure everybody knows about it. So let's go ahead and get through this, and that'll be there. Head first, may I begin thanking you, GCC, for a fine way or very birds of schedule to speak to us. GCC is a compiler we've been using, right? It's made by the GNU team, GNU project. There's another one called CLang, which we're not using. That's not a problem, my friend. A pleasure to help. Head first says, GCC, can you speak many languages? Is that true? Yes, I'm fluent in over 6 million languages, forms of communication. Really? Just teasing, but I do speak many languages, C obviously, but also C++, Objective-C, and I can get into Pascal, Fortran, PL, 1, and so forth. Oh, and I have a smattering of Go. Considering when this Head for C book was written, that's pretty interesting. That there's actually a conducive Go compilation there. I would never do that. Don't dream of compiling Go with GCC. That's a bad idea. Head first. And on the hardware side, you can produce machine code for many platforms. Virtually any processor, or generally when a hardware engineer creates a new type of processor, one of the first things she wants to do is get some form of me running on it. How have you achieved such a thing, such incredible flexibility? Considering C was created to make Unix. My secret, I suppose, is that there are two sides of my personality. I have a front end, a part of me that understands some type of source code. Written in a language such as C? No, my front end can convert that language into an intermediate code. All of my language front ends produce the same sort of code. What? You say there are two sides to your personality? I have a back end, a system for converting the intermediate code into machine code that is understandable on many platforms, and to that, my knowledge of the particular executable file formats for just about every operating system you've ever heard of. Head first. And yet, you are often described as a mere translator. Do you think that's fair? Surely that's not all. GCC, well, of course I do a little more than simply translation. For example, I can spot errors in your code, such as, well, I can check obvious things such as misspelled variable names, but I also look for subtler things like the definition of variables, the redefinition of variables, or I can warn a programmer that if you choose to name variables after some existing function, and so on. So you check code quality as well then? Oh yes, and not just code quality, but also performance. If I discover a section of code inside a loop that could work equally well outside a loop, I can very quietly move it. You do a lot. I do think I do a lot, and I like to think that I do, but in a quiet way. GCC, thank you. The reason people are moving to compiled languages today in the modern world, so why Go and Rust are so popular right now, and Julia, and anything that uses CLang, Crystal, and a bunch of other languages, is because these languages are fundamentally safer to program in, because all of them, because they catch a bunch of errors up front that interpreted languages do not. And interpreted languages being JavaScript, Perl, Python, Ruby. So, you know, Java is an interesting one because it's both compiled and interpreted. So we won't get into that one. We probably should, given the Log4j error, that just the biggest vulnerability in history came out today. It's been out, but it's getting fully understood now. So C is your friend. B, the compiler. Each of the C files on this page represents a complete source file. Your job is to play the compiler game and determine which of these files will compile, and if not, why not. For extra bonus points, say what you think the output of the compile file will be. All right, let's do it. Include.io, main, int card 1, if card. Oops. Anybody see a problem here? I can see a problem already. Do you see a problem with this one? Huh? How about this one? What's the difference between this one? 1 or 2? 1 or 2. Yeah, where are the braces? You caught it. There's no braces there, right? This one needs them. You can only omit the braces if it's only one line after the if statement. And even then, that's sort of a bad idea, because you might end up doing in JavaScript, which will do automatic semicolons insertion and ruin your day. So generally a good idea to put the braces, even if it's only one line, in my opinion. B, it's got semicolons. Okay, this one has got, wait, this has only got one. This one's only got one bracket, so that ain't going to work. And this one's got one bracket there and no other bracket. So the only one that's actually going to compile is C. Let's see if we got it right. Be the compiler solution. Each of the C files, blah, blah, blah. A, the code compiles, the programmer displays small card, but it doesn't work as properly. Okay, so I guess I didn't realize it would compile, but which is kind of bad, actually. The fact that that compiles at all is like really bad. B, the code compiles, the programmer displays nothing, and it's not really working properly because the else if matched to the wrong if. Yep. The else here, the if here goes with this else. Those two go together. Yep. Okay. I don't know how I guess it's valid code. It's just not doing what you think, right? Because it's actually valid. This else, because there's no indentation, right? So this is essentially the same as saying if blah, 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 else put s. This stuff all goes together. That's why that's compiling. And the if statement without an else is totally fine to do. Yeah. So this code won't compile because the braces are not matched. There's only one branch here, and there is no other branch, so that doesn't compile. All right, great. What's the code like now? All right, so this is what our card game is supposed to look like. I guess our first game in our game dev C night is going to be blackjack. So all right, here's our card. Here's all the stuff we have so far. Developing Python Linux script. No, I'm in the middle of a C course. Make sure you look at the calendar, but at another time possibly. There's a lot of people here that can help you though, so throw that out to the Discord channel or to me at another time. But right now we're doing C coding. So we're on topic. We're on topic. Yes. So if you look at the topic, it'll tell you what we're doing right now. All right. So here we have a scanf. It scans in the card name, and it checks the values to see if it's gone up or down. This is our card counter program. Is there something we can do with that sequence of if statements? They're all checking the same value, and most of them are assessing the value as 10. I wonder if there's a more efficient way of saying that in C. We already did this, so we're kind of ahead. C can perform logical tests with the switch statement, pulling a switcheroo. We've already done this, so we're going to scream through this. Sometimes when you're writing conditional code logic, you need to check the value of some value over and over. To prevent that from having lots of if statements, the C language gives you switch. And so does Python now, as of I heard like last year. That's a big deal for the Python to add it. They made a big deal about not adding it. The switch statement is kind of like an if statement, except for that it can test for multiple values of a single value. So boom, 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 right? And you need to put a break here. So if the train is equal 37, add 50 to the end. So if it's 37, switch train. If it's 37, it's pretty. Yeah, somebody told me that Python had a switch. They informed us of that like last time we did C class. Yeah, I haven't got it before since then. Okay, this is important though. Look at this. See the break? What does that do? The break goes out of the brackets and continues on with this line down here, or wherever there were a line down there. If there's no break, what happens? It falls through automatically. This is very important because that is different than Go and Rust. This default behavior of C has been one of the greatest annoyances of the C language since the beginning of time. We've been putting breaks in everything and annoyed by it. So the new default behavior of most of the modern languages default to fall through. Default to break and not fall through. You have to put fall through instead of break if you want to fall through. This, however, falls through. So it runs this line, and then it runs this line, and then it runs this line, and then it runs this line. See, and then also add 20 to the winnings. So that's kind of a thing. Here's your switch statements. It's showing you how it's going on visually. When the computer hits a switch statement, it checks the value was given, and if it looks, and it looks for a matching case. When it finds one, it runs all the code in that block until it reaches break. The computer keeps going until it's told to break out of the switch statement. This is super important in C, especially if you learn to code in Go. It's actually also one of the reasons that I want to teach people C before Go, because I think it's more important that you know the default C behavior and know how Go has changed it from that, given, the history of the languages. Missing breaks can make your code buggy and dangerous. Most C programs have a break at the end of each case section to make the code easier to understand, even at the cost of some efficiency. So there you go. Look at this section of your code. So how can we improve this? We already did this. So we already did this, in case you're wondering. So, but I'll show you. So we already did ours. See there? I kind of did it without asking. So K, there's no lines here, so they fall through. So K, Q, and J all fall through, do 10 and break. And A does its thing. All right. So that's what this is, the original one. They're trying to explain it to you kind of in a slow way. Do you think you're getting the switch statement? Yes, I just did it. All right, so hey, look, they gave us the same one. Case K, Q, and J goes to 10, A, blah, blah, blah. Huzzah, we were right. Bullet points. Switch statements can replace the sequence of if statements. Switch statements check a single value. The computer, this is true in C only. In Go, you can have switch check lots of different things, including the type. So another reason Go is awesome. The computer will start to run the code at the first matching case statement. If you continue to run until it reaches a break or the end of the statement, it'll just keep going. Check that you've included breaks in the right places, otherwise your switches will be buggy because they'll fall through and do stuff you didn't expect. It's a really common error in C, so make sure you watch for them. Why would I switch instead of if? If you're performing multiple checks on the same variable, you might want to use a switch. It's just easier to read. The main reason I do it is it's just way easier to read. Come on. This particular logic right there, if you were to write that, you can't say in, like in Python, right? You can't say card name 0 in a set of KQJ. You can't do that. And you can't say is card name equal to K or J or Q, because that's thinking like a human, which is, by the way, a really fatal error in Python. People do this all the time. This is a really fucking fatal error in Python. That is a logic error. I'm going to show you one of the worst logic errors in all of Python history. All right, check this. Okay, so we're going to say foo equals 3, and we'll say if foo is greater than 2, print yes. Okay. Well, all right. So there we go. Now, this is what people do. If they check individual values, right? So you can say if foo equals 3, print yes. All right. I'm gonna simplify this because you can just say, you can just do the condition by itself. This is Python. I'm trying to show you the danger of Python here. Foo equals 3. All right, foo equals 3, right? Does foo equal 2? No, it doesn't. But here's where it gets interesting. What if you wanted to say if foo equals 2 or 3? Right? Then you do something like this. If you're human, you go into this thinking like a human. You have no idea how many times I have had to correct people on this. Over 500 people that I've taken through my mentoring skills. This is the most common logic error in all of Python for beginners who think like humans. They do this. They say, okay, well, if foo equals 3 or 2. But here's it looks right, right? It's not. It's not right, but it's not right in a very insidious way. In a way that's almost impossible. That logic errors are the worst possible. This is another reason I don't like people who say how Rust safe is. Safe Rust is. The logic errors are the worst ones. They're the ones that kill you, and they have nothing to do with memory overflow. And I'm about to show you why this is a huge error. So foo, let's try something different. If foo equals 5 or 6. Oh, that's false. Okay, got it. What if we do this? What do you do? Foo. Now let's do an evaluation on that though. All right. So let's force that last one into be a Boolean. Actually, it's capital B, I think. Oh, it looks like they finally caught it. They finally caught it. Oh, no. I messed it up. Equals. Look at that. What just happened? What's the value of foo, everyone? Why is foo equals 5 or 6 true? Make damn sure you understand this, because this will be asked of you on some sort of test somewhere in Python or in a coding interview or something. You need to know why that's true. What's the fix? What's the fix for that? Why is 6 true? Anybody want to take a dab? A stab, not a dab. Right. Because 6 is being evaluated as true. Here's why. If I force 6, the number 6, into to be looked at as a Boolean by the computer, the interpreter specifically. Whoops. That's a primitive, sorry. You'll see that it thinks 6 is true. It gets crazier. What do you think it's going to think 0 is? Anyone? False. Right? What does it think 1 is? True. What does it think -1 is? Also true. What do you think it thinks the word false is? True. If that confused the shit out of you, good. Make sure you understand what just happened. If it makes sense to you, great. But a lot of people don't understand this going into it, beginners in particular. And this foo equals 5 or 6. This is exactly how a human thinks. But the computer needs very explicit. It's trying really hard to help you, which is bad. If you did this in a strictly typed language, it would fail. It would say, "I'm sorry, I don't know what the fuck you're talking about." But if you do it in a loosey-goosey language, like, languages like, it's called duck typing, because if it looks like a duck, quacks like a duck, must be a duck. And so Python's like, that 6 looks like you want to use it as a Boolean, so I'm going to use it as a Boolean, and I'll convert it for you. JavaScript's even worse. Oh my God. So any of these loosey-goosey interpreted languages are probably going to fuck you over eventually if you don't pay attention. So you got to be really careful. This is also why strictly typed languages are all the mode right now, because people have discovered that this is not stable. So the way to do this correctly, as somebody's already said, when teaching unit testing as obvious success, test case passes better are required. Yes, absolutely. Absolutely. And test cases they pass all the time, and they actually are failures. So be sure you know about this. So the actual way to do this is Python again, but it could be the same in JavaScript or Node or TypeScript or Dino or Perl or Python or any other interpreted language, loosey-goosey language. So if foo equals 5 or foo equals 6, which can be written just like in C if you want. You can put the logical operator. It just has a tighter binding. Actually, no, you can't. Interesting. Must have to have a looser binding. Did not know that. Oh, I'm confusing JavaScript. Sorry. Some of the, Perl and JavaScript allow it, but not Python. I mix my languages up. So there you go. That's true. But why is that true? What is that one actually confuses me. Oh, we made foo 5. Yes. Let's make foo equal to 3. Foo is 3. Now we have a false, right? And we go back to this. Oh, look at that. It gives us 6. So, and in that case, we can do, if we were to convert that whole evaluation, we would see it true. All right, so I think we covered this to death. So, I mean, that's a Python thing, but I'm trying to show you why, languages like this are a little bit better at evaluating things like that. Let's go back to the book. Single value. Twitch can check a single value. And remember that whole thing about typing, right? So we're going to be talking about that a lot. Sometimes once is not enough. Okay, it looks like we're going to move into loops now. So we did basic if conditions, and then we're jumping into loops now. So basic logic, we did functions, now we're doing values. I don't like that they didn't really cover types in this book. They expect you to know types already. They did strings and character arrays, but they didn't really talk about ints and stuff. I wish they would have gotten into it a little bit more. But we'll just proceed. Oh, do while. We're not doing do while. Does anybody actually use do while at all? I hate do while. I don't use this. Don't do this. You just make sure you understand what it's doing if you see it. The only thing do while does is ensure that something happens at least one time. That's it. How's it going? M&A. I'm on VQ. We're going to do loops, 2 cards. Oh, crap. You've learned a lot about the C language, but there are still some important things to learn. And I find it very interesting to learn from you. Thank you so much for saying so. It's very kind. Scalderon P. So do while, biggest culprit of infinite loops. Yes, don't do it. Just don't do it. Don't do it. Always start your loops with a condition at the top. A init check change is what I call it. I don't like the way this is teaching loops. But I have a lesson approach to teaching loops that I call it init check change. So we'll talk about that in a bit, and you can memorize that. Init check change. Every loop in any language uses init check change. Sometimes it's just an implicit. So kind of new here. Haven't used this account in a long time. How's it going, Sims? What do you do, and what is this? We are doing some C coding right now. You can have a look at the About page if you want to get some more information. Here you go. You can go read about that. But we're doing some head for C programming right now. Okay, so hey, Jim. You're here instead of the stuffed animal. Okay, fine. So using while I do have a schedule. In case you're wondering. Using while and a job. So what if you want to program and do something again? Wait, do we have to add that clip? Do we have to add that clip from YouTube? I didn't say I was efficient. Again. Teletubbies. How it used to be like small. Why are these like so long? I'm totally distracted. Again. Do it again. All right, fine. Again, part 4. You know, kids like repetition. There's actually a psychological reason for it. Pretty interesting. We'll come back to that another day. It's true. Mac and cheese while watching this. Okay. Here we go. So we're back to the book. Using loops in C. Loops are a special type of control statement. So that's the big fancy ass academic word for this. We're using control statements. A control statement decides if a section of code will be run, but a loop statement, I'm sorry, a control statement is if it should be run. So logical control, should I run this or not? A loop statement decides how many times it should run. And the most basic kind of loop is a while loop. A while loop runs over and over and over again and until while the condition is true. I call this condition the check. And that's going to make sense later, but I want you to remember that now. So this checks the condition before running the body loop. So the body doesn't happen until that's the thing. Remember, bodies are fence. The braces are like fence posts. You leave one off, stuff falls out or breaks out. When it gets to the end of the body, the computer checks if the loop condition is true. If it is, the body can run again. This is really basic stuff. Sometimes you don't need brackets. See this here? Just don't do that. Honestly, I've been doing it a little bit. Don't do it. There are so many reasons this can go wrong. Okay? So, first of all, if you get used to writing code without braces around it like that, I guarantee you will do that in a language that does. In JavaScript, if you write this code, it will try to jam a semicolon right there and it will fail. Actually, that's not completely true. Sometimes it works. But it's bad practice. Why? Because 9 times out of 10, you're going to come back to that code later and you're going to need to add an extra line. And when you add the extra line, you have to add the brackets anyway. So just take the extra time to put the brackets, the braces, whatever you want to call them, the curly brackets. And I have huge errors from omitting the curly braces. Yes. And thank you for saying so. Thank you for saying so and for following. This is a practical thing that coders have figured out over time. They're so tired of like dealing with their own errors. Take the initial time. Another practice I do, for example, you'll see it's kind of annoying. Anytime I need a double quoted string, I will make both double quotes at the same time and I'll go back into the middle of it and I'll change the content. The reason for that is because if you wait, you'll get writing a whole bunch of stuff when you open the opening paren or the opening bracket or the opening quote, and you'll write a bunch of code and you'll forget that you need to close that shit out. And so you'll end up leaving an error in there. You'll avoid the error up front if you write, and some code will do this, some code stuff will do this, VS Code will do this for you automatically. I don't like that because it makes me lazy. But if you do put those things there, put the opener and closer, and then go back into the middle, and then start adding your stuff, and then that'll keep you from making really common errors. Braces and emphasis combining conditions too. Yes. Yes. So JS when there is one line after a condition is infer that it is a return, which will make your conditions exit early. Absolutely, Jim. And so this code right here is pretty damn fatal in JavaScript. Especially if you have an if statement or something there. It will not do what you think. It will do this. It will evaluate the condition with the if statement. Here, I'm going to show you. Better to show than to tell. So we're going to run node. I'm telling you why, even in C, you should get into the habit of using the brackets and just always do it. Always. Go forces you to do it. But if, because one of the things that's great about Go is the people that made Go also were involved with making C. So they know all of these gotchas that have been around for decades, and they made sure to put them in the language so you can't even do that shit. And it's made the language very unsexy, but very clean and clear and safe because you can see what's going on. The most unsafe code is the code you can't understand. Keep that in mind next time you compare a Rust program to a Go program. Which code is safer in terms of being able to understand what is happening? Not necessarily a memory buffer overflows. The most unsafe code on the planet is the code that's hard to understand because code is read far more than it's written. All right. With foot guns. I know. They really are. So, by the way, if you're a hacker, it's great. Now you know what to look for. Particularly in JavaScript. If you know about these gotchas that programmers make with these errors all the time, make a list of them. Write them down. If you're a hacker, if you want to break into somebody's computer or you want to do whatever, you want to discover like $5,000 bug bounties, make a list of all these common things that programmers don't do, and then look for that shit. Search for every return statement. Search for every if statement, and you will find it. You will find in some of the biggest code bases in the world, you will find that there are programmers who have major bugs in them right now. That logic error I just showed you, you will find people doing shit like that. In Python, you'll find people making these errors because they haven't caught them because they are really hard to catch. I'm going to tell you why. And this is why when someone says a language is unsafe, I'm like, oh yeah, watch me write a ton of unsafe code in Rust because without even breaking memory safety. Because it's the safety is about clarity and logic, and that's what's most important. So if we do Node.js, we're going to pick on Node.js today. So if you do this, if you say let's say, okay, so foo, let foo equal, thanks for the follow there, if sum, and so we have foo's been defined, right? Point it with the whole log4j vulnerability, absolutely. Absolutely. I've been doing log4j all day. It's been making me crazy chasing down this is the biggest flaw. It wasn't in Python, it was Java. That's too bad. I should get the Java Android. Where's the Java? I need the Java. Get that about page. All right, so let's do this. So here we have a program, right? So watch this. So I'm going to do it correctly first. Okay, so we say this. We say if foo equals, which is, I did this on purpose. That's an error. You should use 3 equal signs in JavaScript. If foo equals sum, I type code from the Rust book and started at the code because it wouldn't compile at the end. I just copied the code example, but I can see the typo. Yeah, Sarah, you know what? Thank you for that example. I keep harping on these other parts of coding, and I don't know if it's because the Rust community doesn't acknowledge these are the main issues with programming, or if it's they just don't give a shit because they have their agenda and they want to push their stuff onto everybody. I don't know which one it is, but whatever it is, it's very scary because they don't talk at all. If they really cared about safe code, they would be on a holy moly rampage about all of these problems that I'm talking about right now. So here we go. Here's one. So if people don't appreciate readability. They call it unsexy. They call it, oh, I could write that in my sleep. It's because they think that they're smart if it's harder to read. They think that writing brainf for Perl, like really compact, obfuscated Perl, makes you some wicked intelligent coder. It doesn't. You know what it shows? It shows how fucking stupid you are because you're writing code for an enterprise or something this is what the log4j thing is. You're writing code that's going to be used millions of times, and you've decided to flex in this code so that everybody else after you has no fucking idea what you did. And somehow you gain some really corrupt sense of egocentricity out of this because you think you're badass because you wrote some really crazy ass code that nobody can understand. The only thing you have proved is how fucking stupid you are because everybody after you understands that they're not going to understand your code. Clean code, people who write boring as fuck code and lots of it and make really wicked safe code, those are the amazing people you should seek out. And they're not going to flex in their code. They're going to flex in other ways. They're going to flex in architecture. They're going to flex by hacking somebody else's smart code. So find another way to flex. Don't flex by writing esoteric code. Write simple, easy to read code, and the world will be a better place. Am I using a directional mic? Kind of. I'm sorry if it's off a little bit. Comments are important too. Okay. Yes, comments are, as long as they're not over, you're not stating what's obvious, then it's just annoying. And exiting fast code, yes. All right. So here's the way, I would say to write this probably. You put it if statement, say console.log. We'll say, oops, I forgot to make this. I got problems. I'm failing because I'm doing it as a console. You know what? Fuck this. Let's do it as a script. Let's just do it as a script. Foo.js. User, let's see. Vin Node.js. Where is Node? I probably have to do an env on this one. I don't normally do this. Fuck it. Which? God damn it. Give me a sec. This keys, which Node.js. User bin, okay. Oh, whoops. temp foo.js. That's why I was confused. Damn it. Come on, Rob. User Node.js. All right. So if foo equals, and we can use single quotes because strings. I'm telling you some JavaScript. Console.log. Yay. Sum. All right. And then we'll let foo equal sum. And I don't need semicolons, but whatever. So, you know, and it was a slight delay on one, and it was hilarious. Goodness, how well people around them too. Yes, I love that statement. To get you into quiet mode. Yes, it gets me into quiet. It's probably good that I step away from the mic to rant. So, does this look okay? Yeah, okay. Let's run it. Temp. Oops. Schmucks. Temp. That's just okay. Schmod plus x. Temp foo.js. Temp. Actually, I don't like extensions, but I did it because. All right, temp foo. We run it. Yay, it ran. All right, so what do we got here? We have, so this ran. Now, that is fine, right? We expect that to run, right? Let's change foo to other. What are we going to get? Oh, no, it didn't print, right? Okay. Now watch. Watch what happens. What is foo? Should this print? No. Let's get rid of the quotes of the brackets. What's going to happen? Now, I think it might work. I think they might have fixed this. No, they didn't. What just happened? Nothing. No, they did fix it. They fixed that one. They fixed that particular case. They fixed that particular case. There's another case where this fails, though. Oh, I can't remember which one it is. You think this hasn't changed? All right, mind's eye. Help me with the other one then. There is a case where this fails. Let's find it. Numbers. No. What is it? No, the same line works. The same line works. I can't remember. That's what I get for doing this live. There's definitely a case where this fails. I think it might be functions. No, that's a different thing. That's a different thing. That's this not being the right number, right? What I want to do, I want to make it do this. There's a way they make it do that. There's a way to make it do that. Here, I'm gonna search for it. I don't want to waste your guys' time, but since I brought it up, let's go find the answer. JavaScript, JavaScript use of brackets, automatic semicolon insertion, ASI. I wasn't planning on doing JavaScript tonight. But I write same thing with brackets and semicolons, so it does exactly what you mean. Yeah, I think there is a way to do this. I'm trying to find a way. Return, break, continue, throw. What are restricted production is encountering and contains a line terminator in a place where the grammar contains an annotation. Oh, it's return. I think it's return. Yeah, it's return. I forgot. So you have to do a function. 10 more minutes will be add a Docker file. Shut up. So continue return. It's return. Yeah, I forgot. So if you have some, oh, I'll do function foo. I forgot. Yeah, it's only, I think it's only on return actually. All right. So we're going to return. I don't know why you would do that though. Return something. I like to experiment. So something. Okay, let me do foo. All right, function. We got my JavaScript is so rusty right now. Who's already been declared? Oh, whoopsie. Var. That's because I did let. It wouldn't even tell me that if I did it with var. All right. So bar. Okay, so console.log bar and it prints something. All right, so if you do this, nim and poo, if you do this, it will, that I think that's the one that fails. Yep, it does. See? And so, I mean, it's stupid to do that, but it's the returns the one that fails. There are a couple other cases that I just don't remember offhand. But the generic C if statement is good to know. I'm really glad we tested that because that is not as dangerous, but I still think you should do it anyway because it's really easy to get broken there. JavaScript quirks as a service. No, we're not doing that. We're not doing that, but you can go read them all to yourself. So anyway, there's so many quirks in JavaScript. We'd be here all night. Anyway, don't do this. All right. Don't do that. Put brackets. The end. Everybody agrees, including the hardcore C and JavaScript people. We all agree. Let's just the beginners don't know that. Now they do. Loops offer more of the same structure. Did I say that? I probably will. I need to clean that up in my. I'm pretty mean in my Zelcast. Yes, loops. You can use the while loop anytime you need to repeat a piece of code. Do something simple as a loop set a counter. So that's the init check change. Have a simple test condition on the loop. Do something in the loop like update the counter. This is what I call init check change. That's my trademark. TM RWX Rob. Init check change. Let me show you what I mean. So, well, they have it here. So this, if you think about init check change, every single loop other than an iteration, which is we haven't covered that yet, and C doesn't have it. Every single loop has init check change. There's an initializer step where, in that instance for an integer, not initialize, there's an initializer step outside of the loop, sometimes in the loop if you're using for loops, which we're going to get to later. The init is the situation where it says, okay, what is the first value going into the loop? And then we have the check. The check is a condition that it checks for to see if it's true. If that's true, it will execute the loop. Otherwise, it doesn't. And it just exits out and jumps past the loop. And then we have the change. The change is usually at the bottom of the loop. Okay, so we have init, check, and change. Init, check, change. And that's how you can think of your loops. And when we come to for loops, you'll understand that it combines the init, check, change into one, which we're headed into now. So, and the for loop makes this easy. So in the for loop, we have to initialize the counter here. Actually, you can initialize the counter in here now, I understand. I'm going to do a for loop test here. Where can you find this? This is in Head First C. It's a book called Head First C. There's PDFs out there. It's a copyrighted book, but I'll leave that up to you. I bought 2 copies. So Head First C book, yes. So here we have the init, right? But in the case of C, in this particular example, this has been combined. Now, what I understand is I want to test this because I believe in C11 this has been combined. You can actually put int here now. So I'm going to actually test that. If that's true, that's the way I would prefer to write code. So we're going to do for, you can. Thank you guys. For loop. We're going to do for loop test. We're going to write a little for loop test. And I got to remember to do my things here. Include studlib, stdio.h, and then we'll do for, let's do for loop. So for int I equals 1. Normally it would be 0, right? But let's say 1 here. Check, what's the check? Init check change. So we say I, if I is less than 10, I'm going to say is less than or equal to 10 so that we get an actual number. It'll count to 10, otherwise it won't. And then we say I++, and that will just add 1 to it after. At the bottom, it's like putting it at the bottom of the loop. So after it exits the loop, it'll run that. And we should be able to put s, let's do this, printf. God damn it. I was just taking the conversation earlier. Like some dumb code I wrote once upon a time. Let's see. Semicolons and where do semicolons? There is no semicolons. They're inserted. Go has automatic semicolon insertion as well, but you're supposed to run it through the linter or it won't compile. So you don't need to do I equals 1. You can do I equals 0. This case, I want it to print something. So I don't want it to print 0. Let's print I number foo. And then we'll do I. So, and that can all go on the same line if you use brackets. Or even if you don't use brackets, I think. I'm pretty sure. So let's make the for loop. So ASI is irrelevant. Oh, right. If you do it with a nested for loop, you have created a self-destructive worm. You can destroy anything it comes across. Replace to change every file in a system to this. Oh my god. Why would you do that? What have I done wrong? I did something wrong here. Less than or equal to for identifier expected before or. My C knowledge is kind of off right now. Is it commas or not semicolons? I'm telling you, my C is like showing. Did I do semicolons? Huh. Oh. This is why I am doing these little tests to help me remember all this easy shit that I should have remembered. Now you know. We have to put it in main. No, you don't need main. Dude, that's the kind of thing I would forget without beer. All right, for /for loop. There we go. So we got our loop, and it's nice and pretty. So we have an int check change. How would we do that with a while loop, though? Let's copy it. Copy for loop to while loop .c. And this is why Go got rid of for. There's no such thing. Go got rid of it. They're like, no, it just costs the compiler time. The only loop there is in Go is for, is while. No, for is the only loop. They don't know a while loop. And instead of while loop, they use what's called a forever loop. I'm like totally backwards tonight. So anyway, let's do this. Let's do the while. Let's do exactly the same loop in while. So init I equals 1. While. And this is exactly why Rob Pike's like, fuck that. We don't need 2 loops. We don't need that shit. We don't need that shit. It's the same exact thing. As you can see as well. Yep. Get rid of while and make it forever. That's dumb. It isn't forever. It's not. That's just when people want a while. They always ask, well, what if I want to loop forever? And he always says use a forever loop. And he always grins a little bit because he likes the wordplay. It's a forever loop. He just write a forever loop right here. But he's actually right. He's right. There is no need for 2 loop syntax keywords. There's absolutely no need for it. It's the same thing. It's exactly the same thing. So he loaded up the for syntax so you can do multiple initializations in one line in on the thing. Yeah. So let's go back to that. No, no, we're not going to do that. Don't scare them, Ancient Straits. You know how you get around that? You do what Go does. You know what Go does? Go says you cannot put an I++ on a line with something else unless it's in a for loop. It has to be on its own line. It has to be on its own line. You know what? They didn't even cover that. This book is kind of bad because it hasn't covered that. All that does is add 1. It's the same as adding 1. I feel bad about that in this book. There's a lot of things I would prove in the book, actually. It's not as explicit as I would like. They said you should add a program first, but, you know. Back owners, yes, I equals 10. By the way, all that stuff that we just did with the int check change, same thing in most other languages. Let's do a Go one. Actually, you can do it. You can do it in Bash, right? So for I equals 1, I is less than or equal to 10, I plus plus, do echo, actually printf, we'll just do s dot foo, I, done. Oops. What am I missing? For I do error near syntax. I'm doing something wrong. That's what I get for shooting from the hip. Oh, we need another one of those. Thank you. There you go. Oh, whoops. We need to put our line return there. Same thing. All from the command line. Don't you want to learn Bash? I didn't have to compile or anything. I just use it. I love Bash. I'm a big fan. So here we go. I think we got loops covered pretty well. When are you going to teach Bash? During zit. We're going to do Bash during Bash, POSIX, and PowerShell native. We're going to learn all 3 shell languages at the same time. When Python and Go together, C by itself, and Bash and all that. Becoming autodidact is going to start on May the 4th. PowerShell will be fun. I have never learned it, so you can bet I'm going to be struggling on that one. Source management with Git and GitHub. That's a thing. And then we're going to go from there. So these are the things that are coming up. After day 1. No, we decided that it was a fucking waste of time. When the admin is a total waste of time. Yeah, we're like, no, we're not doing it. It's like, I would rather learn stuff that's going to get you someplace. It's not even that I'm stuck. It's like, I have no desire to do it. You know, what is finished in that list? There's lots of finished in this list. This one is finished. This one's finished. I don't have videos made for them yet, but this stuff's all this content. All of this content is all of that content, and this has been finished. It's just in my old skill stack repos, and I have to pull it out, and it's all written. There's no videos for it. It's all stuff that I've been teaching live. I have lessons on this. That's why I can kind of like some of them roll off the tongue because I've been teaching it forever. But I have never made any. It's going to take me a year to make all the videos, so that y'all can see it eventually. And I of course I'm cleaning it up as I go. So yeah. So that's why you're not seeing all that stuff right away. But that stuff's all coming. Every day I'm back now that streaming is a lot easier and I can do the co-working thing while I stream. It's going to be more regular. The 8 to 9:30 every day is going to be a more regular thing. So 90 minutes every night. If you just come in here, if you want to do whatever, and I'm trying to see how much of that stuff we can fit on the annual calendar. But we might have to go longer than a single. I don't know. We're going to have to see. There's a lot of stuff to cover, and I don't know if we can cover it all in a single year. That's a lot of shit to learn, man. And I got to stop diverging, but that's how I operate. So, and then a lot of people who are here, they only have this 90 minutes to work on shit. So they're not, yeah, it's probably 2 years. Yeah. I encourage you to stick it out, even if you're doing this for learning. Persistence and working through a hard problem is useful too. Yeah, I'm not into there are so many other better things to learn besides the admin of code. And I would rather encourage people to learn coding basics before they throw themselves into the advent. And like, if they're learning how to code as a part of that, great. Oh yeah, okay. For loops are ancient, used a lot in C as much as more fun. If you have extra time, for sure. All right, so here we go. You use break or break. Okay, so break prematurely ends the loop. It also ends an if statement. This is really, really useful. I use this all the time when I'm parsing, when I need a block that needs to eject out. I wish I could show you that, but my pagan processor, I use that a lot. It's a really, really great thing. I even use for loops that only iterate once because one of the conditions is that it will break because you can't just use empty braces without a block with no while loop on it. The break statement is used to break out of loops and so also for switch statements. The break statement will break you straight out of the current loop, skipping everything else. And the reason I'm using a book here is so that you can go to the book and answer your own questions if you want to go deeper. You have something in the body vague for is completely valid. In Go it is. Yes, in Go you can do that without the semicolons even. VMT. Tell some breaks don't even breaks don't break if statements. What? During HTTP's legacy telephone system crashed, 60,000 people lost their phone service. A developer working in C code using Exchange tried to use a break in an if statement. Oh my god. That's someone who's writing shellcode who made a mistake. This is so fucking important. I have to check this right now. Not stupid, yeah. I gotta stop saying stupid. So let's say that is super important. I have to fully understand this right now. So break test. I'm doing this over and over because I want the practice. So if let me see. If true, is that gonna work? Put us something. Make break test. Something. All right. How's it going, Red? So here we go. Break statements not within a loop. Okay, so this is good. This is why we have this turned on our compiler, because it gave us the error. Now, what I want to show you with that, I'd like to make a little encapsulating thing that shows what's up. Let me show you this if I do this with bash though. So if I do break test dot bash, I'm just comparing the languages because I have to, because I use them both all the time. That's what got that AT&T person problem. So if I do if true, then phi break printf made it bash break test bash only meaningful in for a while and until loops. Nice. Now I just need to put a set-e on that, and that will save us. Nope, didn't save us. Fuck. That should have saved us. Interesting. Well, make sure you do shell check on that. Break is only valid in loops. Good. Well, that's good. I mean, there's a little sidebar there. I want to adjust it. So we're done. Schmox is Schmo plus X. It's easier to type. Yeah. There are some places that it's valid, and that's what I'm trying to remember. I just can't remember. I can't remember which one it is right now. I don't think it's JavaScript or Node. I don't know if it's Haskell. I don't know, dude. I can't remember. I don't feel like testing them all right now. It doesn't belong there. Let's just put it that way. Yeah, there's some. I'm pretty sure that some languages have just like a plain bracket. Schmox is just schmod plus x. Hello, I'm just lazy. Sorry. Yeah. All right. So anyway, continue is the one that skips up to the next one. This continue is in pretty much every language. I think continue is in every language. If you can find out that where that's valid, that'd be cool. But I'm not in the mood to go look at them all. So continue is valid. This like just exits out of your loop early. It's easy. You're like, well, why would you want to do that? Sometimes you want to. Sometimes like if you have a comment, like a really common reason to do a continue like this. So let's say you're parsing each line of a file, and you're reading every line, and you want to skip the comments. Any kind of recursive descent logic, which is kind of above this for now, but that means you want to have a block of code that evaluates, and you want to have the things that have priority at the top, and anything that fails, you want to say, okay, this doesn't meet the criteria. Let's loop again. And when you're writing a parser, when you're writing a language parser eventually, which you'll do eventually because it's really fun, this is the kind that you really want to. You're going to use a lot of continue. In fact, you're going to use goto sometimes, and goto is actually labeled a bad thing. But there are really substantial cases where goto is really good, including the Go compiler. It's all over in it, because it's more efficient than a continue, which goes all the way to the beginning of the iteration again. So goto is not the devil, absolutely not. Misused goto is definitely the devil. Goto used in the proper way is the means to get an extra 10% efficiency out of your compilation and parsing. So you have to know what we're talking about there. So don't go use goto unless you really know what you're doing. Most of the time, something like continue is going to be better. But so yeah, has been valid outside of loops or switches in C ever? Not in C. VMT. I wasn't thinking. I'm trying to figure out what language it is. It has been valid outside of loops. There is at least one language I have a feeling that does allow it, and I can't remember which one it is. Because I remember using that as a, well, I don't remember anything. Let's just move forward. So, anyone allows it? If no one allows it, that would be really great news. That would just be me remembering things bad. And no, I wasn't the person who made the error on AT&T's long distance phone system. No, I don't know. You can use the break with the goto on the same time. Lol. Dude, goto works. And really, look, if you don't, me and Rob Pike agree that goto is worth using if you're making a very kick-ass, the world's fastest compiler. You have to borrow break? Really? Interesting. All right, so continue, since that's what we're on, continue goes to the top of the line. So let's say, for instance, you're parsing a bunch of lines in a file and you want to skip all the ones with comments. So you have your while loop, right? And then at the top of the while loop, you say, if this line has a comment in the beginning, then continue. Boom. And it goes to the next line. Pretty basic logic. 10, go to 10, 20 break. Shut up. Right. Writing functions up close. Before you try out your new loop, Mojo, let's go on a detour and take a quick look at functions. Why are we talking about functions now after we've been using them all this time? I don't like this writing style. I like the sing-songy stuff, but I don't like the order. The order is all over the map. I'm really big about doing things in the right order. I have belabored whether I should do functions before logic for years because everything is a function when it starts out. So far, you've had to look at creating one function in every program you've written, the main function, except for my attempts to not have a main function. So int main, and then this stuff goes on its own line. I've been putting on a line up here out of bad habit because that's what Go and everything else does. But I support putting it down here and see if you can break yourself with that bad habit I have. The body of the function, the part that scrolls. So you have all that, and then the return statement at the end, which I've been omitting every time, which is also bad form. In C, I understand, but that's fine. The main class, I didn't say main class. Please tell me I didn't say main class. If I say main class, I should just walk away right now. I did not say main class. I said main function. There are books that will tell you that's the main class. Somebody was telling us the other day. So, yeah. Anyway, pretty much all functions in C follow the same format. For example, this is a program with a custom function that gets called by main. Was it me? Was it you who said that? So, int larger, and then it has, what are these called? What are these called? I want to hear what y'all say. This is false. Okay, this actually, the wording of this could be considered true if you get really pedantic about it. These are called parameters that take arguments. So it says the function takes 2 arguments. That means, what do the arguments go into? The arguments go into parameters. But this is the parameter signature. Function signature, parameter signature. This is telling you what parameters are allowed in. What are the buttons? What values is it going to take? So if larger, if you could think of f of x, you could think of f of a comma b here. So if you've ever done any kind of algebra, that's what this is about. And the int tells you what's being returned. Go uses reverse notation. Rust uses reverse notation, but we'll argue about that another day. If a is greater than b, return a, return b. So this is actually, that's interesting because that's actually the kind of thing you would do in Go. I don't know if there's a name for this type of logic, but rather than putting an else statement, let me ask a question. Why is an else statement here redundant? What did you find? What did you find? Volatile in C? The volatile keyword in C is nothing. The C, I don't even want to look at it. I've got it open, but we'll come back. Because the return exits prematurely. Right, you got it. You got it. This is actually my favorite way to write conditional logic. You'll see me write in Bash like this all the time. Because what's the alternative? The alternative is to put an else there, and then you've just I don't like having unnecessary indentation. It's actually a really strong Go convention. Stylistically, Go, people who code in Go, they won't tell you this. There's some style guidelines if you're going to submit to some of the Go projects out there. But there's been argument about whether you ever need else. The problem is that you should keep your blue sky scenario. You should keep your main line of execution left justified. The thinking goes that the code should be as left justified as possible. If you find yourself with 6 to 8 to 10 levels of indentation doing something wrong, you need to simplify the code. You need to figure, and you're going to confuse people, and they're going to introduce bugs, and people are going to die. You don't think I'm kidding? Go read the Camry transcript, the Toyota Camry case against them, class action lawsuit. People died because of that shit. So make simpler code. One of the ways to make simpler code is to left justify as much of the code as possible, and throwing an unnecessary else in there distracts your eye from the main execution. And then what you do is you put your exceptional cases, like, the things that are generally not the main thing, they go into the if statements. And then the main stuff stays on the left, and your eye can glance over it. This is another reason Rust is horrible, because you can't follow the code that way. The reason Go gets called unsexy and nobody wants to code in it who likes obfuscated languages is because it's so easy to understand. Oh my God. Look. Yes, people sometimes do that. Sometimes people will put a comment for else like that. Both paths are equally main here. I don't agree. So people, people, we can agree to disagree on this, but the Go convention is don't use else unless you need to. Just because it just makes it easier to read. This also doesn't have any parentheses on it, which makes it really tricky, because if you didn't have 8 spaces of indent, like they don't, that's why I have 2 space indent. One of the reasons that the C conventions are really strict about 8 spaces of indent is because If you start screwing up your indentation, if your code has like 5 levels of nesting, it won't fit on the page. That's one of the reasons they like doing that. Oh God. I love early returns and keeping things flat. Me too. Keeping things flat is a nice, fast, easy way to say that. Yes, thank you for saying that. Learning the hows, whys, and quirks programming. What advice do you give out learning to think like a programmer? Problem solving as a programmer. I don't know. I don't have any. I would just break the program down. Most of my programming doesn't even happen in front of a computer. It happens while I'm walking around, or I write it down on paper and I break the steps down and I organize the domain language and the schemas and things like that. That's the hardest part of programming, actually. And that happens. It doesn't have me. Some people do that in front of a keyboard and they're like deleting a ton. Every time I see a YouTuber or a Twitch user, a Twitch coder who spends so much time typing really, really fast, and then they delete it all, and then they type something else, and then they delete that, and they type it. I'm like, you know what? If you stayed away from the keyboard and you thought about what you're doing, and you maybe wrote it down on paper, not only would you save yourself carpal tunnel, but you'd end up writing cleaner code. But a lot of people think in front of the keyboard, and if that's your thing, that's fine. I don't like it. I think it's a waste of time. Oh boy. So, I write my code out by hand. All of my main code, all of the most important algorithms I have, I write them out by hand. You know why? When I write by hand, it slows my brain down. It slows my brain down. It causes me to focus on what I'm doing. And you see how many times I make an error when I'm sitting in front of the screen here, especially when I'm talking to you guys and you're all heckling me. I'm going to make tons of mistakes. And that's fine because we're just learning together. This is kind of fun. But don't think for a second. When I'm coding for myself, I'm putting the earphones in. I'm not listening to music, and I'm breaking down a really complex algorithm or a data model, and I'm giving it maximum effort, and then I'll bring it back, and then I'll tweak it and put the code around it when I bring it into the thing. That's my style. There's a lot of people who have different style there. I am not a really fast programmer. I don't find value in coding quickly. I find value in creating high quality code that has been well thought out. And if I am going to just kind of, screw around and do some rapid applications experimentation, I'll do it in Bash. That's why I love Bash so much. In Bash, I can experiment with lots of different things really quickly and make them work. And then I can come back to it and I can think, okay, now how can I solidify this a little bit? How can I shore it up a little bit? So you'll see a lot of messy Bash in my scripts and codes and stuff then I come up with ideas like command box and things like that are, in my opinion, real breakthroughs when it comes to organizing code for Go and things. And those things wouldn't happen if I just coded everything just off the cuff all the time. And so those are some processes you can look for. Then you can be ported to anything and fill out the coding according to my outline. Yes. Int greatest equals larger. Okay, so it's taking a comparison. Okay, printf I as the greatest. So this is your first function call. Looks like we should probably do a function call. The main function has an int return type, so you should include a return statement when you get to the end. But if you leave the return statement out, the code will still compile. Then you may get a warning. So I've been writing it without return statements because I'm bad. And I'm going to start to fix mine. Let's fix all mine and add return statements, shall we? I'm going to open them all up and add return statements. Return 0. Return 0 is true, right? I don't remember. Let's do that. So let's do, was that adios? Make adios. X's name. Some. Nice knowing you. Echo. Yep. So the exit return code 0. So that means it was 0. That means there were no errors. There were 0 errors. You just do exit success if you get the macro. Yep. All right. So, and that's the same as Bash. So that's the thing. I'm going to open my programs up. I'm going to add this. I'm gonna add it to all my code and then I'll recompile. Why did this all do that? Oh wait. That doesn't make sense. This code is not right. It must be fixed. 8 space indent. Oh, it's got too many indents. I see. Choo-choo. Do 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 do. This is lazy, I know. There's a better way to do this. I need to spend some time on my Vim and get all the C stuff clean. Yeah. All right. Put this here. Why is it doing that? Oh, because these are not indented right. Yeah, because they were 4 spaces. I wasn't planning this. All right. WN, that means write it and go to the next one. Your backdate spaces, yes, I am. Uh-huh. Uh-huh. Damn it. Damn it. My editing fails. Hey, that one has it. Okay. Oh. Damn it. All right, I'm going too fast. These are all so weird because we tried so many different things while we were doing this. I should just make a macro. I know. I should do a million things. This last one. Shift-Z. Yay, they're all changed. And I could probably add some things to this. Do. Git ignore. All right, ls.c bash. I'm gonna take off the .c .c, and then let's put a chapter in front of them. Is repeat, put in front. Put in the front chapter. I need to make a code for that because I've been doing it so much. Might as well. There. God damn it. There. Yep. Commit. Remove. As the add returns to all functions. There we go. All right, back to the book. 8 to 9:30. We got a few minutes left. Teletubbies. Goodbye, Teletubbies. It was fun knowing you. So, do we want to write this function or not? I guess we probably do. We just say, should we write this? Let's write this program. So we're going to write our first function. And I'll write it just called function test. I don't like these because they're not fun. They're okay, but they're not fun. Normally when we do this, it's fun to have a thing with it. vi func test.c. Oh, God. .c. Again, include, which you could probably have a macro for. but I don't want to. Stud. Oh my god. io.h int main. When my code's getting better. Return 0. See, that stuff could all be written for you when you like open up a new C program. You can do that as a macro or something. But I want to do it because I'm going to learn it better. 2 spaces is not the standard, so I don't want to do that. Yes, you could also define a macro for that. You absolutely could do that. Есть кто с России, я из России. Я не из России, но все равно. Visual mode, ways to get roasted. Visual mode is shit. I hate visual mode. I hate it. It doesn't work on anything but Vim, first of all. Space is not time. Oh god, here we go. So we need to write another function. So printf, what's the goal here? The goal here is we want to say the number I is greater than, how about than I? Okay. So we say, and then we can say return 0. Hey, thanks for the follow. So we can say if greater, and we could say n comma x comma y, or n comma m, or whatever the fuck, I don't care. So we could say int n equals 100 and m equals 200. And we can make another function up here, int greater, takes in 2 ints, int m, int m. And in Go, you can actually combine those. You can do int m comma n. You can do, okay, we'll just get confuse people. So it's actually really cool. Now, this function is also done like this. So what are we going to return? I wonder if we can return a condition itself. Can you return a condition? You can, right? I'm going to try it. Can you return a condition? I'm about to find out. If n is greater than m, this will be fun because I don't know if you can do this. You return the evaluated value. You can. All right, so make func test. Shit. One triggers errors, return 0. Oh. Damn it. Before return. It doesn't look like it likes it. Oh, thank you. You guys have great eyes. I thought we could use I for ints. Oh, I didn't pass any. God damn it. Print F. We'll practice some of that logic I was talking about. Oh, right. Thank you. Func test. The number 100 is not great. Did I do it backwards? The number 100 is not greater than 200. Oh, no, we got it right. So I think we can actually change this, and we can do int n, int m, right? Can't we do that? I know we're jumping ahead, but I think we can do this. Not for ifs. That's right. Yes, I don't know why, but that's what in argc. Uh, do we want to do argc right now? No, we're not gonna do it. Okay, fine. Fine. I have to recompile just to test the code. I don't remember the arg signature. I don't. I know it for Go, but I don't know for that. The number 200 is greater than 100. Okay, our code is working. Yay. So, commit, let's see, add func test. Time for me to be done. What the heckling? So, let's see. All right, so let's go back. We covered that. The Roman function int argc char double pointer argv. And that's the number of arguments. Yeah. It's been a long time. You have to pull that shit out of os.arg args in Go. So that's why I'm out of practice. Yeah, I don't want to get into character performance with argument variables. They're waiting on that too, you can tell. The larger function is slightly different than main because it takes arguments and parameters. It takes arguments or parameters. An argument is just a local variable that gets a value. That is false. This is categorically false right here. An argument is the thing that goes into a parameter. A parameter is the variable. They're not synonyms. The larger function takes two arguments, a and b, and then it returns the value for which is larger. Why did they say anyone can learn to code? Well, we're coding C here, Terry, so don't freak out. Yeah, not everybody can learn to code. And this is C coding, so you can learn to think like a computer. Anybody can. You already do. You think like a computer all the time. You just have to understand the similarities. And they'll ever be good at it. Yeah. Saying shit like Steve Jobs says that everybody should learn to code because it teaches them to think is absolute bullshit. There are a million ways to learn to think, including learning a foreign language. That will really, really teach you how to structure math too. Learning math, learning a foreign language. This is why math or a foreign language are both the optional things you can do in America in the curriculum, school curriculum. But to say that everybody should learn to code is stupid. Should everybody be able to be a critical thinker and deconstruct arguments and steps and procedures? Yes. If people can't follow regular, written down procedures, and that's because they have a hard time reading and deciphering and processing logic and stuff. That's true. But everybody can code. It just takes time. Not everybody can learn to code. There's people I've worked with a couple of people. One person was dyslexic. It was practically impossible for him to learn to code. It was very, very hard to have that conversation. There's two people I've had in my community over the last 9 years that I had to have a meeting after they'd been here for a long time, and I had to have a sit down with them, and it was pretty hard. And one of them had dyslexia, and it was he could have done it. He could have definitely done it, but it would have been massively painful, and it would have been constantly way behind all his competition. And that doesn't mean he shouldn't code. If he enjoys it, if he enjoys coding, then fine, do it, but do it on the side. Don't do it as to make bread and food and stuff. And there was another guy who had autism who his dream was to become a game developer, and he had so much passion. Oh my God, that's got to be one of my hardest moments ever. It was one of my hardest moments ever. Is no matter how much I struggle, I've been working with him for 2 years actually, and he had a lot of fun, and we hadn't really handheld him. We let him kind of stumble on his own, but he still, after all that time, he would have a problem understanding things like if statements, and he couldn't spell at all. He couldn't remember the way to write the words. He had no sense of indentation or anything. He just really wasn't getting coding in general, and it was really clear that he was going to really, really massively struggle his whole life. And it was so hard. It was so hard because he dreamed of being a game developer because he had this fantasy idea about what game development is. People who do game development don't even get to play games because they're coding for 90 hours. I saw an interview with one of the guys who did, was it Evolution? What's that game where one person's the monster and the other people are the team and they have to take down the monster? It was like, there's a YouTube interview with the guy who coded that game, and he's like, oh, I don't play games. He's like, what? Like, no, I haven't played games for years. Evolve, yeah. One of the lead developers on Evolve was like, what are you talking about? Because they were interviewing him on YouTube. You can go find it. And they were saying, hey, God, this must be so much fun to be a game developer. He goes, you must like really love testing the game and playing. He goes, no, I don't do any of that. Like, I just make sure the movements are working. He's like, very matter of factly, he loved his job, but he hadn't played a game in like years. At least it sounded like it. And so, you gotta dismiss the fantasies in your head about what coding actually is and what it's going to get you. It's not always fun. Sometimes it's really hard work. But if you enjoy it, go for it. Do that kind of thing. But it's certainly not for everybody. What's that? You can be raised to include returns and voids if you want to stop the function's execution. Yes. And that's, I do that all the time. I actually love doing that. I love bailing out of functions early all the time. It keeps your code a lot simpler. I do that in Go all the time. And Bash, actually. I'm not 100% how the refs are implemented in C++ fundamentally. I figure your assertion isn't wrong. Yes. It's hard work for Log4j Java people this weekend. You can bet you. Yeah, including us. We've had to dig through code. We have quite a bit of code that's exposed. All right, so here we go. Void functions up close. SSH containers. Yeah. To the point where it looks worse than HTML. A new alternative to SSH. Oh, God. Most functions in C have a return value, but sometimes you might want to create a function that has nothing useful to return. Void. It always reminds me of the Dota character, Void, in the Void Spirit. It might just do stuff as rather calculated. Normally, functions always have a certain return statement, but if you don't want one, just leave it off into the void. You don't need a return statement, but if you want to put a return statement, you can return without a value, and then you can bail out of the function early, which is a really great way to keep a simple left justified code. If you want to do your logic that way, I really love that. There are no dumb questions. If you create a void function, doesn't mean that it can contain a return statement. Yes, you still can do it, but it just can't have a value. Really, why not? Because if you try to read the value of a void function, the compiler will refuse to compile. Yep. That's why you have strictly typed languages, right? You try to do that in JavaScript, it'll let you try. There's no compiler to check you. Or Python or Ruby or Perl or Python. I said Python twice. So what's better? Remote code execution was better than SSH? I did not get it. I did not get it. I didn't get your... Was that the gatekeeper paradigm? Does it have a name? What is the gatekeeper paradigm? Where did you read it? In Uncle Bob's book or something? It's all OOP though. Decides that the information should move to the group individual. It takes a mental health gatekeeper. Is it actually a thing? DM rant. Dungeon Master. Correcting the gatekeeper role. Gatekeeper mutations. In programming, how about that? Programming paradigms. I shouldn't have put. I don't. If it has a name, I really want to know. If you can find. If you can find a reference to that, I appreciate that comment a lot. The chosen one. If you can find a reference to that chosen one, please let me know. I would love to find that. I would love to add that. Oh, the stream's done. The stream's done for the night because I'm going to quit. I'm going to quit RC coding for the evening. It's completed. We did voice functions. Guess what? We are at the end of the chapter finally. Huzzah. There's a bunch of assignment solutions at the end, but we are done. I think we're done. Yep, we are. So tomorrow we're going to do all of these extra functions, which I think we've already done. And we're going to make sure and review them all, and then we're going to say goodbye to chapter 1. Okay, so that's going to happen tomorrow. And we'll say goodbye to chapter 1 and we'll be on to chapter 2. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many chapters? 11, 12, 13. Oh, there's only 12 chapters. There's only 12 chapters. So the last chapter is going to be a lot of coding. Blastoids, we're going to have to figure that out on our own. It's going to be really fun. I can't wait. So, because it's got a lot of pictures and projects and stuff like that, VMT. Yeah, that's why you pay for all that fun mnemonic stuff. A book or two. So think of the trees. Think of the trees. All right, so we just got done. We're gonna do chaining functions. We'll do change that. This is where we are. We'll pick up tomorrow. We got 7 pages left. Lord Rubbish, we're gonna go. I'm gonna drop the stream. I'm gonna come back. I'm gonna be setting it to just chatting for now, and I'll probably play a couple games or 2 before I go to bed. I might finish. I kind of want to finish my bash code that I started because I really want to get that thing working. So, and it's kind of relaxing. So I'll probably end up working on that. Thank you for joining me and failing with me and